on conventional sand casting and 3D sand printed mold casting. This presentation is done by Shivam and Anthony Chan. So, conventional sand casting is one of the most commonly used casting methods. It's a standard process that most people use to create large metal parts. You usually start off with a physical piece, typically made from metal, that matches the shape of the final part you want. The piece represents what we ideally want our casted part to look like once it's been finished. You place that piece into a mold, which is then covered in green sand. Green sand is a mixture of sand, clay, and water. Once the part is removed from the newly created mold, it leaves behind a cavity in the shape of the part. When we pour hot metal into that cavity, the metal is then given time to cool. The larger the cavity, the longer the molten metal is going to take to solidify. Thicker regions within the cavity will also cool at a slower rate compared to thinner regions. Once our casted part cools, we break open the mold and we're able to remove the newly casted part. Sand casting has been used for hundreds of years because of how cheap and effective it is. Sand casting can be done on almost all types of metal and can be used to make automotive parts like valves, engine blocks, cylinder heads, brake drums, and even heavy equipment parts like brackets and frames, as well as platforms used to support heavy machinery like lathes and milling machines. There are pros and cons to using conventional sand casting. The pros are that this method requires a low tooling cost, which makes it very cheap and allows you to produce parts in both large and small quantities. Another benefit is that this allows you to it can be used for most metals, this process. It allows you to make parts in various shapes or sizes. You can also use conventional sand casting to make parts that are, very large in size. Overall, conventional sand casting is an excellent way to make a large quantity of high volume parts. The cons are that you won't have the best finish. A lot of times the part is going to have a pattern left on it from the green sand. Another issue is that parts won't have high enough dimensional accuracy, meaning the shape won't be exact. As a result, you'll need to machine them afterward. This machining requires extra labor time, which increases the overall cost. It's also difficult to use sand casting to create parts with complex geometries. Another drawback is that the mold requires a lot of prep work. The preparation time needed to create each mold can be long and also adds to the cost of each part.
So now we move on to 3D printed sand mold casting, and before we continue, we must know the difference between the two. In conventional sand casting, we have to make a foam structure of what we want to make, and then we can continue and make the cast. But in 3D sand casting, we don't have to spend the extra materials and machining time to make that foam structure anymore. Instead, we just need to make a 3D model of what we want to make and upload it to the sand 3D printer, and it will make the structure for us. The unique thing for 3D sand casting is that the 3D printer will actually make the structure, and instead of making the structure itself, it will make the negative of it, which means that it actually makes the cover or the shell of what the structure should look like. So the inside is hollow and it is the shape of the structure that we want. It is way more precise and you can add a lot of fine details to it. This saves us a lot of time, effort, and money. After that, you may be curious how a sand 3D printer actually works. So first, the machine lays a thin layer of sand and a nozzle comes by and sprays thin layers of binder onto the sand, which holds the sand in place. And it does that layer by layer by layer until the structure is done. The sprues and the gates will already be programmed into the model by the programmer to make sure everything flows correctly once metal is poured in. But after the metal is poured in, you would let the metal settle and cool down and solidify just like you would do in a conventional setting. After the metal is solidified, the sand is actually removed and you will have the structure that you need. So this is only a one-time use mold because the mold has to be destroyed to remove the wanted cast. So here on the left is an example of a sand 3D printer, and it's making a pattern on the bed of the 3D printer. And on the right, you can actually see a product of what a sand 3D printer may produce. As you can see, they're actually also making the inside of the shape, not just the negative or the hollow part. So this may be due to specific specifications, like if the person wants to make a pipe, so they need the inside to be hollow as well. So they may include that centerpiece right there. In this case, it looks like they're making some kind of a turbo. So what are the advantages of this type of sandcasting versus the conventional sandcasting? So one huge advantage this has over the conventional way is the fact that it has very high dimensional accuracy, which leads to being able to make very complex shapes. And because you can make very complex shapes, you don't have to machine it as much when you get to the end product when after casting the metal and after the metal solidifies. On top of that, you never have to make a foam structure of your end product anymore because that will also take up more time and money. Another advantage of this type of sandcasting versus the conventional sandcasting is the fact that you don't have to make the foam structure of your end result anymore. You can just upload the one copy of the 3D model of what you want over and over again, and you can reproduce it very accurately every time, which leads to another advantage of this type of sandcasting. It is very high in reproducibility. As you can see on the image on the right, these are some pretty complex shapes, and all those holes that are created there, you don't actually have to machine those, which saves you a lot of time and money, and time is money, so it saves you a lot of money. After discussing the advantages, so what are the disadvantages of this type of sand casting? So there are still rough surfaces just like traditional sand casting. It is made of sand after all, and you will have to polish it afterward if you want it to have a smooth and shiny surface. The size is also limited to the size of the printer itself, so you can't make an object bigger than the 3D printer itself. The 3D printed sand mold is less strong compared to the conventional sand casting, and because of that, it is limited in size as well. So it can make things from medium size to small size is its happy range. On top of that, you have to run the machine for a really long time because it has to print every single layer, and the machine is quite big, which means it uses up a lot of electricity and energy. 3D sand printing is the best option when trying to create complex parts like turbine housings, EV motor housings, intake and exhaust manifolds, or any cast that requires a lot of small cores. 3D sand printed molds are better when working with cores, as they create internal channels throughout the part. The benefit of 3D sand prints is that it is toolless. You don't need to build a physical model like you do with the conventional sand casting. The tooling used in conventional sand casting can take weeks to make and cost several thousands of dollars. With 3D sand prints, you can create a mold in CAD and have it printed within days. 3D sand prints are best for low volume quantities because the tooling cost is lower, so the cost per part will also be lower. Conventional sand casting shines when you need to reproduce parts in high volume or when you need to produce big chunky parts with few cores inside of it. It makes more sense to use conventional sand casting versus 3D sand print when designing parts with high tolerances. The benefits of conventional sand casting is that you can lower your cost per part once you've invested in the tooling needed to make the part. Another benefit is that conventional sand casting allows you to produce parts at a faster rate.
Look at the limitations of 3D sand printing. The main limitation is that the printers that are used to print the molds are very expensive. The process is also slower when you're using a large printer to print something because the part is so big that it's just the print time is going to be a lot. And we also have to like kind of rotate the part, and it's just the whole print time, the whole print process is very tedious and is expected to take a lot of time than using conventional sand casting. Another issue is that the printed sand is weaker, and that the sand used to make a conventional, like weaker than the sand used to make a conventional mold. And the printed sand is more likely to crack. Another issue is the surface finish. The surface finish is still rough, which means you still need to machine the part to give it the appearance of a near net shape. The final limitation is that we can't really use this process to create high production volumes of parts. This is because our cost per part would be too high compared to conventional sand casting. As a general rule of thumb, when working with quantities that are less than 100, use 3D sand printing. When creating over 100 parts, it's best to use conventional sand casting. We're now going to look at the manufacturing readiness level of 3D sand printing. I would give 3D sand printing a manufacturing readiness level of 8. The benefit of 3D sand printing is that it allows you to more functionally design parts with the complex geometries. 3D sand printing also gives you more flexibility with the parts that you can create. It's really important to note that 3D sand printing has been adopted by foundries run by BMW, Ford, Laura Mendy, and this shows that 3D sand printing can produce stable and repeatable results. The only issue is that 3D sand printing is still limited by production quantity, printer cost, and by having enough space to store all of the equipment. It's important to note that 3D sand printing is used in selected facilities but has not been fully scaled across the entire industry. This is why it makes me give it a manufacturing readiness level score of 8. Once 3D sand printing gains more reliability, efficiency, and has specific industry standards, I think this has the potential to reach a manufacturing readiness level of 9 or 10. And I'd like to thank you for sticking with us with this presentation, and I really hope that you're able to learn a lot from this presentation. Again, thank you for your time and attention.